we have exploded what we call either the petal diagram or the flower diagram. And we would like each of you to go and identify which petal you are in as your home petal, and then draw lines. There are markers there, and draw lines to the other petals that you connect with through your work. And we're going to gather them all. This is really actually a real social science thing. It's not just fun, it's actually real. We were asked by our steering council to do a social network analysis for AgMIP. And this is what we came up with for how to do it. So thank you very much. Stop by. It's a lot of fun. Mark Corbeils was the number, he tried it out, and I think it worked, right, Mark? I know. Then if you're not there, add it. Exactly. Unfortunately, yeah. So sorry. We apologize for that. They're new. It's not a new team. If your team isn't there, add it in and then draw the connections. Now, we also, is it in the next slide? Yeah. Is there a posted part? What's going on with that, Eric? Okay. This is the second part about AgMIP feedback.
Yeah, just also by next to the posters, there's a little table with post-its and markers. Also, if you want to give any kind of feedback, I mean, particularly on the structure of AgMIP, or not about necessarily the workshop, but just AgMIP as a whole. Really, if you have thoughts and new teams that maybe don't exist that you would like us to have, or anyway, again, anything to do with the structure, anything to do with any thoughts of what you think AgMIP could go, feel free to put a post-it on the board. We'll collect those. And then tomorrow, the first session, which we will start at 8:30 tomorrow, because we will have that 8:30 to 9, we will report on your feedback and also have like an open session for people to give additional feedback if you would like to tomorrow.
Wonderful. Actually, though, it can be feedback on the workshop as well.
Yes.
Yeah.
Just not only on the workshop, but yeah.
But it's the workshop and AgMIP in general. So just post it away with comments. We're looking forward to that in our session tomorrow with feedback from you all. Speaking then report backs, we have a session today on, it's in the agenda for report backs. We're going to combine the report backs from the first day as well as the Monday as well as Tuesday. Everybody gets 1 minute just standing up where you are sitting, and a 1 minute report back about how your session went. Then just you're also going to be seeing this, but just to give the heads up, we're going to be getting our new hats on the way to the group photo. So we capture everybody, and we'll be getting our new hats we'll be capturing all of us with our new hats. There's some things percolating, wonderful things percolating. I don't even know all of them, but for example, we are working on finding a new leader for the maize team. So please, anyone interested, please get with Ken Booty. And there are other things as well. I think a UNCCD group or dryland group forming, interest group forming, and lots of other things as well. So with that, turn over to who is, oh yes, one more thing. Yes, hold on, let's go to the next slide. Microphone. Sorry. Our steering council, we have a wonderful steering council. We're having a in-person and virtual meeting today at lunch. It's for the members who are here and the exec-com. It's in room VC09, which is in this building. Yep, right here. And they're giving us their wise counsel and words of wisdom for AgMIP going forward. It's a great group and really, really helpful. And with that, that's it. All right, who's leading? Anthony and Dillis, please come. Thank you.
Good morning, everyone. We're going into a session on model application in low yield and low data environments. My name's Anthony Whitbread. I'm part of the CGIAR, part of ILRI, International Livestock Research Institute. I'm leading a program called Climate, Livestock and Environment, and I'm based in Dar es Salaam, Tanzania, and the program works right across Africa, Asia, and Mexico. We've just had a project in Mexico.
And I'm Delis Safako Makati with University of Ghana, and I've been working with AgMIP about 12 years now. I led the West African team for AgMIP integrated assessment work, and I'll be co-chairing with Anthony.
This morning's session, we're going to start off with the keynote from Gassion Falconier, and then we're going to go into a panel discussion where the panelists give a few minutes on their topic, and we'll go into some questions, and we're expecting the audience to also ask questions. Now, the topic, it's low yield and low input, low input and low data, so everything low. So this covers many farming systems that crop livestock, low rainfall crop systems, and also the livestock rangeland systems. And I think this session is mostly focusing on the crop livestock, low rainfall systems. And this is right across many geographies, Africa, Asia, Australia, some parts of Central Asia, North Africa, yeah, of course, some parts of the US and Mexico and other places as well. So it's a really topic that we need to be getting better at representing models in. And so often these systems have low data. We have low information for parameterization of models. So that's what the session's about. And with that, I'll turn it over to my colleague, Gassion, and I'll introduce you, Gassion. Gassion's a systems agronomist at CIRAD, which is the French Agricultural Research Center for International Development, in the agroecology and sustainable intensification program for annual crops. And his research is focused on improving farming systems, food security and adaptation in the context of smallholder, low input farming systems. He's been coordinating with his CIRAD colleagues the low input farming systems activity of AgMIP. And he's based in Zimbabwe since 2021, where he's seconded to CIMMYT's Sustainable Agri-Food Systems team, SAS, which is led by SIG-SNAP, and also to the University of Zimbabwe, the Plant Production Science and Technology Department. So Gassion, over to you.
Thanks a lot, Anthony. Good morning, everyone, and hello to those online. So Anthony said it, it's a lot of lows, right? It's low input leading to low yielding, low data, possibly because of low investment. Sounds a bit depressing, right? So I thought I would take this opportunity of this presentation to give you insights on what we're doing to break that low. I wanted to start with what is low yielding, and I'm giving here examples of smallholder farming systems across the globe. Top left is central Brazil, the Cerrados, you see maize there. Top right is the mountainous areas of northern Vietnam, this is the Plenaries. Bottom left is Vietnam again, but you see maize there. And bottom right is Senegal, you see this farmer growing millet. This plot here, each single dot is a crop cut, very accurate measurement of what has been happening in these farmers' fields. The one-to-one line, this black diagonal here, it tells you if the dot falls on this line, the farmer was able to achieve the water-limited yield. The yield that is possible given the climate in the area and the water-holding capacity of the soil. You see very few dots on these lines. It means something. It means farmers in these smallholder systems are not usually able to achieve the water-limited yield. They obtain half of it or sometimes a fourth of it. I think the message here is quite strong. It means low yielding in smallholder systems is not because of poor climate or because of soil that have poor water holding capacity. It's mainly because of management. So we provide farmers with the resources to give the inputs, the nutrients to the crop, to adequately manage weed pests and diseases, eventually they can increase their yield. What's wrong with low yielding? Give this example here is the Myombo woodland, is this beautiful tree, Brachystegia, that you'd find natural vegetation across Southern Africa, Angola, Zimbabwe, Mozambique. This map here, study from a CERED colleague, shows the gray area is this Myombo woodland, decreasing over time as a result of cropland expansion. Farmers want to increase their income, they want to increase their food self-sufficiency, they are clearing the land to expand agriculture. This leads to the decline in the iconic megafauna of the area, elephant, buffaloes, that deliver so many ecosystem services very critical for biodiversity conservation. So low yielding is an issue for biodiversity. It's also an issue, you're very much aware of this, for climate change mitigation. This study here is 10 countries across sub-Saharan Africa. They've looked at scenarios, scenario S1 on this graph here, trying to achieve food self-sufficiency towards 2050 in these 10 countries with cropland expansions. It's additional carbon in the atmosphere due to the removal of the grasslands and the forest. So low yielding is also an issue when it comes to climate change mitigation. So now why are farmers not intensifying and increasing yields on current croplands? This is results from a long-term experiment in Zimbabwe. It's 11 years of maize growing without fertilizer. That's this first line here. You see that yields without fertilizer are around 1 ton per hectare. Add some nitrogen, you can reach up to 8 tons per hectare. But it's so variable across the year. And one way of looking at this is computing the nitrogen agronomic efficiency. How much maize do you get per kilogram of nitrogen added? It goes from 0 to 60 in these 11 years, and median is 20. And given the current prices of maize, the current price of fertilizer in the region, this 20 is exactly what you need for this strategy to be profitable. So it means half of the year is not profitable for farmer to intensify. Good news, there's widespread recognition that yields need to increase and that commitments, there's a strong political commitment to increase yields in sub-Saharan Africa. This is the declaration, I think, after the Africa Fertilizer and Soil Health Summit last year in Nairobi. African leaders committed to increase access to organic and mineral fertilizer. AgMIP, the low impact smallholder group, is acting in this specific context. We want to know, in these contexts of increasing productivity, what's the impact of climate change and climate viability? How can our crop model help? I will try to give you insights on what we've been doing so far. And then there's this idea as well of trying to go beyond fertilizer varieties as adaptation strategy. Try to give an example of how crop diversification and agroecological practices can help. And by doing so, I'll also try and touch upon this idea of going from low data to high data. This is a brilliant study from Antoine sitting here in the room. We've been looking at long-term experiments. Long-term experiments are great. We found 4 across sub-Saharan Africa, 1 in Ivory Coast, 2 in Kenya, and 1 in Zimbabwe. Left panel is the decline, the observed decline in soil organic carbon over time in these maize plots where you're using no inputs in the form of organic or mineral fertilizer. There's not enough biomass going back to the soil organic carbon is declining. And so are the yields. In 2 of these 4 sites is significant, the yields are declining. There's not enough nutrients to the crop to sustain high productivity. We used 14 crop models to try and simulate this behavior. So the black line here is the median. You see that somehow is far from perfect, but the good news is somehow this model ensemble is able to pick what's happening in terms of declining soil fertility and the feedback and yield. We've used that ensemble to predict what would happen in the future, looking 30 years ahead. No climate change in this first blue dots. What we see here is that the benefit of integrated soil fertility management increases over time. And it's overall across the site, 190% increase in yield. Climate change. We've looked at changes in some climate variables. Here I give the example of 25% decrease in rainfall. Yields will still increase, less so, 170% on average across the sites. But yield will still increase. It means there's a no-regret strategy. You can intensify crop production now. It will still be good in the future. And I think this is a different message from what we currently hear on climate impact studies in smallholder systems. You would find very often we've investigated the impact of climate change on maize, yield will decline by X%. Which yield level are we looking at? And here I think we're looking really at this intensification path and the impact of climate change. I think is more insightful in this context. It talks to climate justice, I think. If climate change is going to constrain the scope for intensification in smallholder systems, well, I think there's some sort of international solidarity that needs to happen. There are heated debates happening at the moment at the COP. I think our role as scientists is to come with the accurate numbers. How much will the scope for intensification decline? Of course, we're facing some challenges. The first one is, as always, the experimental data. We try as much as possible to calibrate our models. Here are examples of what you need to accurately calibrate the water balance in models. It's observation of soil water. You see that we could find 7 experiments across the African continent. But unfortunately, this red area here, where water goes below 50% of what the soil can hold, we have very few observations. It means in most of these experiments, on-station experiments, and we don't have this water stress that we're looking for. We have no observation on soil supply of nitrogen, also an issue. And this graph here, I've tried to hide it somehow, but now it's there. That's the simulated nitrogen response, 25 maize models in our initial low input study. You see that it's all the way 0N from 0 to 10 tons, depending on the sites, but it means that these models, they're simulating soil organic matter mineralization and supply of nitrogen to the crop in very different ways. So the control yield is very different from one model to the other. The potential yields and the water limited yield is also very different. And in the end, you end up with all these different responses. We've not stayed arm crossed and wait. We've tried to take the bull by the horns. I don't know if it works in English. In French, we like to say this. And we've tried to implement this experiment that we're looking for, these golden experiments where you're monitoring and measuring all the variables that you need. This is what we were able to achieve in Zimbabwe, thanks to the great help of University of Zimbabwe. It's an experiment that has been running for 2 years now. We're looking at rainfall treatments. These white gutters here is this idea of excluding 20–30% of the rainfall. We also have treatment with ambient rainfall, what climate will provide, and also an additional treatment where we're looking at intense rainfall is 100 millimeters of irrigation per day during different time of the growing season. This is just example, observed water in the soil. We see that there was last year El Nino, drastic droughts toward the end of the season, the type of data we need to calibrate our model. We're trying to measure as much as possible the nitrogen balance. We're looking soil mineral nitrogen uptake by the plant. And here I think is an interesting result from last year. You go from reduced rainfall to ambient rainfall to high rainfall. You provide more water to the crop, you'd expect the nitrogen uptake to increase. It's actually decreasing, and it's really showing that leaching is something that happens there and very critical to understand how these systems work. Now trying to look a bit into crop diversification. This is a farmer who works with us in Zimbabwe together with Simit and Sirad. See that this farmer is growing maize, the tall plant, also growing groundnuts, the smaller plants. And these two plants, they have very different development cycles. Maize longer duration than groundnut in this region. And you see that critical development phases happen at different times. The grain set period, the red bar, the green area here, happens earlier in groundnut and is much longer. We've tried and calibrate a crop model based on this on-farm data, look at 30 years of historical weather, computed deviation to maximum yield as an indicator of how the crop is sensitive to climate variation in a given year. You'd find years where there's high deviation for maize. It's a lot of water in the beginning of the season, creates some leaching, impacts the maize, but does not impact the groundnut because the groundnut's relying on nitrogen fixation. You also have other type of growing season where there's water stress at the start of the season, impacts the growing set of groundnut, but maize not so much impacted because it's still vegetative phase. There's really this idea of in one specific location to look at different crops and how they are sensitive to climate change. This picture here I took last year when I was in the mid-Zambezi Valley. The impact of El Nino, very contrasting if you're talking about maize or if you're talking about sorghum. Maize is failing here on the right, while sorghum is thriving. Are our model able to reproduce this? This is something we're trying to investigate. We're lucky to secure funding for a PhD student. We really want to look into that question, gather as much as possible experimental data, so if we can check whether our models are right to depict this. You can have two crops separate in different fields. You can also mix them in a single field. This is intercropping. The good news is that Adam is here in the room. He's now leading an intercomparison exercise. It's been describing the different models, their assumptions, their concepts. You see that now there are many models around that can handle light competition, water competition, and nutrient competition in intercropping. So we're now busy trying to start a new exercise on intercropping. Another agroecological practice, agroforestry. Here, this is sorghum grown under Federbia albida, this beautiful leguminous tree. This is a type of parkland you find in many parts of Zimbabwe. You find it in Senegal, some parts of Ethiopia, around the Limpopo River in Mozambique, very common across Africa. Here again, I think our models can help. If you go closer to the tree, you have more soil organic matter, more nutrients. The model can reproduce this. If you go closer to the tree, you have less light. The model can also produce the impact on the radiation. There are additional factors at play. The temperature can also be reduced under the tree. There are below ground competition happening, water competition. In that type of parkland, it's rather limited, but in other type of parkland, it could be important. But I think that some of the concepts are already there in our crop model. So it's time, I think, we move to that type of modeling. This is what we simulate at the moment. Anybody who's doing point-based or regional application of their crop models, usually they simulate a single crop. But this is what the smallholder fields look like. A lot of hedges, a lot of trees inside the fields. The good news is, thanks to recent advances in remote sensing, high resolution satellite data, machine learning, we know where these trees are. We know where they are. Any single tree in Africa is now mapped very precisely. So if it's about to change our soil inputs to consider the impact of this tree, change our climate inputs to consider the impact of this tree, is something that we can now do. So I think we should also go in that direction. And now trying to conclude maybe on this idea of going from low data to high data. We often struggle a lot with management data in data poor environment. When is it that the farmer would plant his crop? What would be the typical management? This is data from the Ministry of Agriculture in Zimbabwe. They've been equipping all their field agents with digital tools so that they could go to the farmer and record the planting dates. This is more than 30,000 data points of planting dates across Zimbabwe. You see a huge variability in planting dates. This is what the crop calendars are currently giving us, a very narrow range. It's based on experts giving dates for different crops, some downscaling thanks to remote sensing, but very crude. You see here that the crop calendar is giving the density here, this blue peak, very narrow, whereas the actual observed sowing date, they're very widespread. So it's about, I think, equipping these local field agents with the capacity to do the data, and the data will come. Breaking the law of lows, there's opportunities to grow from low to high yielding, and I think sustainable agroecological intensification can help, but we need to get our models right. So we need more data again, and it's about below ground interactions. I think the old-fashioned core agronomy of drilling a hole and getting the soil sample, have it analyzed for mineral nitrogen, install an access tube, have a sensor that measures soil water. We still need that, and we're struggling to get the fundings for this, but we still need it. Above ground interaction, of course, we need detailed measurement, but there I think the satellites will help us. And when it comes to management, I think it's just recognizing that sometimes the data might be there, it's just that it's not centralized, it's not accessible. So we should also invest more time in trying to refine this. So if we go from low to high data, I'm sure we can go from low to high yield, and it will be critical for maybe hundreds of millions of smallholders across the world. If you realize that you've been sitting on a pile of $100,000 overnight and you're willing to invest and help us, please join. Thank you.
Wait, Gassion. Thanks, Gassion. Wonderful talk. I can remember the 1990s. I know that Mark Corbils can remember the 1980s, but I'll tell you something about the 1990s. Modeling and on-farm experimentation exactly showed what you're talking about. They showed that management, weeding, fertility rather than water in Zimbabwe were often the limiting factor in yields. In the early 2000s, Steve Twomlow, who's passed away now, he was working for ICRISAT, and he convinced the development agencies to distribute fertilizer rather than food aid. And he got them to distribute fertilizer prior to the season. And it averted in some of the really dry areas of Zimbabwe, some food insecurity in that El Nino time. So obviously fertility is part of the system, part of the solution, but you haven't mentioned much about rotations, intercropping, circularity with crop livestock systems. And they are all part of that system, particularly in the semi-arid regions. So maybe take us through what are some of the limitations that we are facing in getting adoption of those systems as well as the fertilizer. And then we'll open it up to some questions from the audience. So think of questions. That's a question for you, Gassion. It was about, you've talked about fertilizer being one of the solutions, but obviously rotations.
Right. On interactions with livestock. I think that's a very critical point. But I mean, we of course it's an opportunity. There's livestock there, and you can rely on recycling the existing biomass in this landscape, rely on the transfers from the rangeland to the cropland. But what we're realizing also that there are limits to these transfers, right? Because in many areas across, well, the smallholder system that we're looking at, mainly in Africa, these regions are limited, and then they can't support high levels of livestock, and therefore the returns in terms of nutrient that you can expect is rather limited. So we need to invest and improve the circularity of the systems. But in the end, what is possible is also limited. We recently wrote that paper. There's agroecology's 13 principle, and one of them is the input reduction principle. And we had this paper saying that for Africa, at least, the principle is wrong because you can't go with input reduction.
Some quick questions, 1, 2 quick questions. We got one there. We'll just take 2 or 3 together, and then Gassion can answer.
Thanks. Very nice presentation. I liked it a lot. But your focus is very much on carbon and nitrogen. What about the rest? There's lots of deficiencies in potassium, in phosphorus, and the devil there is that if you look at for a small farmer, what is his highest return on investment? What should he buy? The answer is always nitrogen. But in the long term, that's killing your soil fertility because you're draining it from all the other minerals that you need. So how should we deal with that?
Thanks. Can you introduce yourself?
Oh, I'm Albert Witt from Wageningen University.
Okay, thanks. Any other questions? Yeah, Heidi, and this side.
Heidi Weber from Zalfen, Germany. So super talk and really nice overview. But you had one comment, I think, on your last slide that you were talking about like going from low data and hopefully that then low data to high data brings us to high yields. But you said somewhere like the need for better models. What do we need models for? What's the role of models in this story?
And final question behind.
Yeah, thanks. Chris Volbert from JASA in Austria. Thanks for the great presentation. I was just wondering, you're often here and you briefly and indirectly mentioned it that the experimental stations are often on prime land and farmers may have quite different soils, for example. So even running the models for those experiments may not fully capture the effects you find in the field. So I was wondering, are there also any initiatives to work with farmer networks?
Thanks very much. You remember those three, Gassian, I hope.
Yeah, I think I'll manage. So there was one on, carbon, nitrogen. What about the rest? Phosphorus, potassium, and possibly meso and micronutrients. Fair, that's very good question. I think you can handle all the problem at once, but this is definitely one. But for phosphorus, I think, phosphorus is, once you've applied it and you're using compound fertilizer, and once you've applied it, it's there, right? So I don't see it's so much of an issue compared with nitrogen, but indeed we need to be careful about this nutrient. And when it comes to micronutrients, we see a lot of time what we see in these contexts is what we call non-responsive soils. You're applying fertilizer, NPK, and you have no response at all because you're missing the calcium and the magnesium. And indeed, that's very important. That's something we're trying to address as well, but using maybe different methods, the nutrient omission trials, and trying to build some more simpler models that we can then use across different areas. And then there was a question from Heidi on why models are useful. I think there was one example on the feedback between soil fertility and yields. This, I think you need a model to assess how the feedback works out, and long-term change in fertility is very critical. And one aspect that I alluded to in the talk is also this idea of variable response. You're applying the fertilizer, in some years it works, in others it doesn't. And there I think that the AgMIP mechanistic crop models are very useful, because anything we do with machine learning or statistical model trying to predict response of crops to climate variability, usually it's very hard to pick the signal because it's confounded and you're trying to use rainfall at the start, middle, the end of the season, but you often struggle. If you have a mechanistic crop model, it's well calibrated, then it's easier to understand what's happening. When is the water stress happening? Is there leaching? The interaction with all these processes. So I think that's why we need these crop models, this idea of variability of response to intensification strategies. And then there was one question on station versus on farm. Very, very critical question indeed. If you think of it, that experiment that I've presented in Zimbabwe is actually indeed what we call red clay soils. It's not what smallholder farmers have in the region. They operate on sandy soils. So it's a challenge indeed. But then I think, you can always have good data on station, you calibrate your model, you validate the processes, and then you can get less detailed data on farm, where you then try and see whether what you found on station makes sense on farm. And what you will always find out is that farmers on farm achieve far below water limited yields. So you rather want to use your model as an indicator of the yield gap there, but also very useful.
Great, Gassian, thanks. That's mother baby trials that SIGSNAP pioneered in Malawi, Zimbabwe in the 90s again. All right, so we've stay there where you are. Gassian, we're going to have the panel come up and Dilys is going to take over.
Thank you very much, Gassian. So we now invite our panelists to join us on the podium, Jacob, Subash, and Diego. Okay, thank you. So we'll start with Jacob. So a brief introduction to Jacob Emmanuel Joseph. He's an agro-meteorologist at the International Livestock Research Institute in Tanzania, and has recently earned his PhD in Göttingen in Germany. He's been engaged with smallholder farmers in East and Western Africa for more than 4 years, assisting in translating weather forecasts into agro advisories. Jacob's work has also heavily relied on crop models, weather forecasts, expert knowledge to design and disseminate climate information, products, services, and improve climate resilient agriculture. So with this, can you briefly give us your thoughts, maybe in maximum 4 minutes, as to your work and as it relates to low data, low input environment?
Yeah, thank you very much. Can you please change the slide for me? Okay, yeah. Thank you very much again for the opportunity. Today, I'm glad to present to you an approach that we have used, and we have proven it that effectively address the problem of data scarcity in low yield environment. Well, this approach is called collaborative fusion of scientific precision and farmers expert. Well, you may be wondering, what is this approach? And here I'm going to break it down. Well, the core process of this approach is about defining and validating threshold that it triggers farmers' decision at a farm level. Well, this approach actually leverages the model capabilities as refined by farmers' expertise and experience. You may agree with me that this process actually remove or simply reduce significantly the model uncertainty in the prediction of the output. Well, so what are we doing with these thresholds? After we have defined these thresholds, then we aggregate them to create rule-based logic, which later on translates to timely and resource-efficient decisions. These are decisions that farmers rely on making. These are decisions farmers rely on doing their daily activities. The execution of this process actually results to development of a product which help farmers to do decisions. Well, an example of decision, a product you can think of a decision support tool, which a farmer own it and utilize it in its daily activities. Just giving an example of what ERI has done with partners. We have used this approach to develop a decision support tool called ISET. And what actually ISET does, it helps the farmers to manage better the climate risk, providing context-specific advisories to farmers so that they can know well how to plan better. And as Gasha said, that management are the key for the productivity. So this tool helps farmers to better manage their activity throughout the season and before the season. Giving practical example of the impact of this tool, the tool has reached more than 200,000 farmers in Africa. And actually it has proved to be beneficial because it has impacted and improved the yields of the farmers. And we have seen the improvement in cereal yields, for example, in Senegal, up to 40% increase. So, ladies and gentlemen, I would like to conclude by saying that yes, data scarcity is a problem, but the way we use the model, it determines how useful how actually we address this problem. And not only that, but what matters most is how effectively and innovatively we use our design space. Thank you very much. Maybe you may see the next slide, just to show what we are doing to collect the data in the field. Yeah.
Thank you for sharing your perspective on this. And I think this is a very important area, given that erratic rainfall is a major issue in low input systems. So it's refreshing to see that we are making improvements with the use of models. So let's go to Diego Pequeno. So he is a wheat crop modeler based in Sustainable Agri-Food Systems program. He also works on a number of collaborations with Summit on Global Wheat program and with a number of other external organizations. His work focuses mainly on simulation of traits, impact scenarios to guide breeding towards most effective traits and trait combination for global wheat production. He also works to determine the importance of single traits or the best combination of traits under different climate change scenarios for cropping systems in key wheat growing regions. He uses high performance computer clusters to run gridded crop model simulations to under current and future climate scenarios on global scales. So Diego, so given your expertise, can you share your experience with us, how you work with your breeding programs and also with the scale of work that you do? How does it translate or relate to the low data input systems?
Okay, thank you. Thank you for the introduction. Thank you for the invitation. I'd like to provoke you to think a little bit different in terms of different perspective of crop modeling applications, especially when we talk about large scale applications. So we also have these constraints of low data and low yield environments. And also we have the same question: can we apply crop models with these problems, with these constraints effectively? The answer is yes, we can do, thanks to different data sources and a very innovative approach. Okay, so just to exemplify you, to give some examples of challenges that we have when we are simulating large-scale areas. So I'd like to number some of the variables and some of the challenges that we have. For example, in terms of input data, we have similar as point-based, but we have imagine to find the sowing dates for a large-scale region. So for that, we use local expert knowledge. We use field stations data, and finally allocation modeling to harmonize sowing dates for each grid cell. So it's something that we do creative to have the best representation of what we have on the ground. Fertilizer inputs. Also, very often we have like nitrogen, the total nitrogen for all the crops. So how to accurately describe how much nitrogen we have for a specific crop that we are simulating, or a specific crop systems and across scale. So that's another challenge that we face. And crop responses, also very similar. What is the phenology of the crops and what is the grain yield? So sometimes we have like district level data. We have national statistics. So working with experts, local experts as well. So to represent what we have in the simulation, to represent what we have in the field. Also biotic and abiotic stresses. So how much of it is happening on the ground? So that's another question that we always ask. How can we separate biotic and abiotic stresses in low yielding, low data environments? Some of the low yielding is due to disease, pest and disease pressures. So it's another thing that we also deal with. In terms of database, I said, thanks to many data sources, we can apply crop modeling to answer different questions. For example, we use crop mask. So it's another challenge to see where are the crops in the field, in a national level, global level. So for that, we often use the crop masks, like the SPAM, the Spatial Production Allocation Model, that estimates crop distribution within disaggregated units. So there are many, that's a big effort that folks in IFPRI does. Also irrigated and rain-fed masks. So where are the irrigated and rain-fed regions? So we have also the same approach. Nitrogen use management, varieties. So what we do with varieties? So sometimes we have the approach that we use here is the MEGA environment. So it's a concept that we try to use to help us to identify regions that are similar across even across continents. So it's not continuous, but they are broad, but they are similar in terms of biotic and abiotic constraints, cropping systems, and consumer preferences. So we also use that to allocate some varieties, to do some simulations. Similarly, gridded soil database also have soil grid and others, HWSD. Gridded climate data, we have many sources, but still sometimes it's a challenge to identify if it's correct or not. So we need to test with some station data, weather station data. We have CHIRPS, NASA Power, ERA5. And also to put together everything in terms of simulating that for each grid cell. Sometimes we have like different resolutions, and we need to separate and to have the simulation for each point in the globe. So we have this point, we need to separate all the input data and simulate all the plant processes in a daily time step for many, many years, sometimes climate change 30 years and so on. So all those things are challenges that I would like to provoke you to think, and also to add to the data, low data, disease, pest and disease data. That is something that it's very necessary for this, for the model application as well. Thank you.
Thank you very much for your insights. So we move to Dr. Subhash. Presently, he holds a position as head and a principal scientist, Division of Agricultural Physics in India Agricultural Research Institute, New Delhi. He has joined the Agricultural Research Service since 1997 and worked, I was going to say 1970s, yeah, 1997, and worked at 2 units within these institutions in various capacities. He has more than 100 publications in peer-reviewed national and international journals with high impact factors. He worked as lead of AgMIP ICAR collaborative projects, ICAR University of Nebraska-Lincoln collaborative research of global yield gap analysis and database administrator. At present, he holds research including assessments of climate change impacts at farm and household levels using multiple models, measurements of greenhouse gases from integrated farming systems, agro advisory services, crops, simulation modeling, rainfall and drought climatology, remote sensing, and GIS are some of the things he's involved in. Dr. Subash, can you share with us some of the frontiers in technology that can be used within these low data input systems?
Yeah, thank you for a nice introduction. And good morning to all of you. And first of all, I would like to thank AgMIP for providing me the opportunity. And I will share some of the experience. Actually, I work a lot of modeling work in India, and this will represent the South Asia region. And as far as India is concerned, India is divided into 127 agroclimatic zones, and which is based on the climate type as well as vegetation. And there is a lot of variability of crops and cropping system across India. And in India, around 80 predominant cropping system exists. So 80, that much variability is there. And another thing is when we talk about India, the Indo-Gangetic Plains, IGP, which is the food basket of the South Asia region, and mainly rice wheat cropping system followed in that region. And basically, even though the rice wheat cropping system in the Indo-Gangetic Plains, there is a lot of variability within the IGP. When we see the western part of the IGP, there is a high input system and highly developed area. But when we talk about the upper catchment of the Indo-Gangetic Plains, there the data is, there is a low data set available for particularly for modeling aspects. And eastern part of the region, that is low input as well as the low data available region. So there is that much variability is there. And we have tried to use some other methodology as far as climatology is concerned, that is climate part. We have a good data set, that is gridded data set provided by the India Meteorological Department. We have good data set for the long-term data, 100 years data set is available for temperature, rainfall, etc. And as far as the soil data is concerned, we have the soil data also, but it is with the government of India. So we need to take their permission to use that data set. And second slide, next one. And when we talk about how we can use the new frontiers for our data, so remote sensing and satellite data integration, that is one option we can do. And we did some work. I will show you some of the examples what we did. And another thing is, yesterday also we have a lot of discussion in the AgML group there, how this ML can be, is it complementary to crop simulation modeling, or it is a complementary, or it is a competitive with the simulation modeling. That yesterday we have discussed. Basically, this will help for crop modeling. We will collect data set using the remote sensing as well as ML. And other technologies like smartphone based and IoT enabled data collection, that is also possible at the farmer level, farmer speed level. Then data assimilation and model downscaling techniques, because we need some of the data sets are available at the global level. We need to downscale into the local or regional level or at the block level or district level. We need to downscale that data set. And generative models are required for synthetic data generation. Basically, we have some of the sites, we have 2-3 years data. Suppose we want the long-term data, we need to develop some synthetic data creation. That is also very much essential for getting some trends. And low-cost edge computing for on-farm distance support. That also we are trying in our small-scale farmers, because as I told, in India, 80% of the farming community under small and marginal farmers. That means they have only less than 2 hectare land for agriculture purpose. Then blockchain for trustworthy and transparent data sharing mechanism also we need to see. Next one.
Dr. Subash, I think we've run out of
just next, this one. Actually, this is some example what we are doing. And basically, we are doing with the Sentinel data set, remote sensing data set for using the radiative transfer model for actually integrated with the ML algorithms, we have tried to estimate different leaf area index, canopy, chlorophyll content, etc. And we have tried to estimate, and we have compared with the measured data. We got a good relation between these two. So this type of methodology can be used for getting a data set in the low data available region. That is one methodology we can use. And next one also, next slide. Actually, in India, we are trying to use the regenerative agriculture. Basically, how to identify the conservation agriculture as well as the general agriculture, that means conventional agriculture, that we have tried using the remote sensing data, and we found that around 92% accuracy for wheat, but at the same time, we have only 83% accuracy for rice. That we are trying to develop, we modify the algorithms based on the actual result. We are trying to increase the accuracy, and that's all. Thank you for giving me the opportunity.
Yeah, thank you. Yeah, so I think we have only time for brief comments for maybe a minute or so for the two of you. So we know most of our farming systems in those areas that are described as low data environments are complex with diverse cropping systems and management practices. Can you share briefly your experiences, maybe just one quick one, on how best you try to navigate these complexities to still be able to come out with something which is good enough to represent the system in which you are working? Just a minute each.
Okay, thank you very much. Yeah, as I concluded my talk, I mentioned something, a design space. The way innovatively use your design space will give you a good product at the end of the day that are useful for the farmers. So giving experience of what we are doing, yes, we effectively use our design space. And how, the first thing when we enter the community, the first thing is to characterize the farming system with help with farmers and expert knowledge. We understand better how the farming system of that particular place work. So again, the next step will be doing a need assessment, and the need assessment will help us to characterize or group the farmers according to their characteristics. So with that approach, then it helps us to tailor the advisories, for example, that help farm the context specific advisory that at the end of the day will be practical to the farmers. So I think the way you approach the problem, it's yeah, it will determine the direction of where your solution come from. We collect data and we find that there are a lot of gaps, quality, etc. But with the collaboration of farmers and the approach that I've showed, we are able to leverage that low data to make something useful out of it. Thanks.
Thank you very much. Diego, can you share briefly?
Yes. One example that I'd like to give you is that we were working with Sudan in some years ago, and we are still ongoing some of the results, some of the papers, but it was very challenging, for example, to work in a country that we could not enter because they were in a war, a civil war. And we had some local people that staff from CIMIT, Mason, that was helping us with the data and trying to get as much data as possible, and also to verify the accuracy of the data and see how much of the cropping systems we could represent, and to help with crop modeling, to run some simulations in terms of what we could advise them in terms of improving the agronomy, improving the practices, to improve the yields. And of course, it's something that was very challenging. So that's what an experience that I'd like to share.
I think He has already answered my question. So maybe Anthony, if you have any question too.
Yeah, actually, you see, the data collection is concerned. When we talk about the data collection, as far as in my experience is concerned, we have in India, we have a network of KVKs, Krishi Vignan Kendras. That means each administrative block, we have the KVKs,
Subhash,
and in KVK, we have different type of subject matter specialists like agronomists, then livestock people, as well as fishery scientists, all are there. So if you can take integrated effort to collect the data at the district level or at the block level, it is possible, but integrated effort is needed. And another aspect is government is propagating the diversification as well as the integrated farming system approach for getting the soil fertility, how we can increase the soil fertility. That is the motto of the government of India. And also we are promoting the natural farming. That is also we are doing. And that way we can integrate all the efforts so that we can collect the data set from the farmer's field. That is possible. Thank you.
I have a very quick question, a very practical one. You're all complex modelers, and we're trying to communicate complexity to our stakeholders. They could be farmers, livestock keepers, policymakers, extension officers. Just give us one quick example of successfully communicating complexity that you're talking about to the stakeholders, and was there an impact? Maybe Gassian, can you start?
That's a tough one, Anthony. Yeah, I have no example in mind. I think, but it's always this idea of being simple without being simplistic. And I think, I mean, this example that I gave today it's not about the absolute impact of climate change on 1 year level, but it's the impact on the scope for improving yield. It's something already quite complex, I think. We wrote the paper, we tried to turn this into press releases and get in touch with journalists. And you see that only this small bit here, it takes time for people to grasp what we're trying to convey. So yeah, I think it takes time.
Yeah, so in Senegal, when we did a post-season survey, talking to the farmer whether the advisory that we gave were useful. So this is what they said. They said for the first time, they were able to understand and utilize climate information service. That was the year 2022 in Senegal. Yeah, the process was very complex, using a lot of analytics and using the model simulation, but you can see at the end of the day, one of the stakeholder, that is a potential stakeholder, by the way, smallholder farmer, was able to understand what the model's output and all that we did. So that I can cite as a good example of how to communicate the complexity to the farmers.
Yeah, so I think we now open to the audience to invite for questions.
Hi, Lennart Jansen from the Potsdam Institute. You talked a lot about getting good management data, but I missed the point of variety selection. If I model something in my crop model, I have a selection of varieties I can choose from, usually calibrated from variety trials, but they're mostly bred for yield potential. But I would assume that many farmers use very local varieties from seed sharing, seed saving, which don't exist in the crop models. Do you think that's a big knowledge gap we need to close, or doesn't really matter because it averages out in the scales we are modeling?
Any other question? Maybe we take two more, if any. Okay, so one here. And then, yeah.
Thanks. My name is Mark Lundy. I'm from UC Davis. A question for Diego. The data set that you described and its extent was really impressive. And I see in different regions of the world, different organizations or individuals collecting huge databases that have similar variables. And to what extent did you have to collect it for your purposes? And how could we do a better job of not duplicating the same efforts for the same variables across regions and for different needs? To what extent could those kinds of databases be more openly shared in your experience?
So there's one hand here.
Hello, my name is Aston and I'm from Agriculture and Agri-Food Canada. I just want to follow up on the question that Anthony raised on communication. I'm wondering if you can perhaps give us a few techniques of communicating to people with low numeracy, for example. I once worked in Zambia trying to teach people now to grow fortified vitamin A fortified maize. And these were people who were actually used to growing crops using intercropping. And just to teach them how to space was a huge undertaking. So I'm wondering if, even Jacob, if you can give us some tips that you have been using in communicating those complex terms like probability, for example.
Okay, so we take the last two, one back here. Okay, last three.
Hello, can you hear me now? Oh, my name is Mbai Chimonya. I'm with Summit, and my question is probably to all of you. Other than Jacob, the people element hasn't really come out strongly. So we're looking at reimagining modeling as we know of it, whilst we are not trying to push those frontiers beyond our capabilities, but there is this recognition that whatever we do needs to serve the people within a particular context. So we talk about data limitations, we talk about low input systems, but these low input systems fit a certain construct, if I want to put it like that. And a lot of the work that we've been trying to do is to push the limits of yield potentials and trying to then impose that ideology into these particular systems. Are we not aiming a bit too far, or are we not placing the bar a bit too high? And hence some of our objectives are convoluted or a bit too ambitious. So that's number one. Number two, more of a comment. So within the CGIAR, we have been working on trying to collate and standardize data across different regions. And this work is being pioneered through CARIB. I know people talk about not having data, but these are efforts that are out there. So how much has AgMIP kind of like tried to look at these different networks that are trying to, you know, bring data closer to researchers? And if so, have you found that data useful, or there's need for us to have conversations on what type of data, how does it supposed to look like, and what can you actually use it for? Thank you.
Thank you. My question is to Dr. Subhash. You mentioned that in India there are various agriculture science centers, and I think I just saw it 731. So how useful is this in this low data and low yield environment, and what kind of data do they collect, and where can we find that data if we need that?
Yes, so the last one, oh, I think, okay.
Excuse me. My question is to Jacob. I would like to know what percentage of the farmers adopt your agro advisories? What is the percentage of adoption and what is the hit ratio in the sense the forecast basis observed in your region? I just wanted to know.
Yeah, so maybe before the responses, each panelist has strictly 1 minute to respond. And then probably during the coffee break, we can interact and then have a more extensive discussion on this. So a minute, strictly 1 minute to each person. Jacob.
Okay, thank you very much. So one of the questions, I'll respond to some of the question, not all. The first one was asked about the technique of communication. Here, capacity building come into picture. So we trained lead farmers who later on trained the local farmers of how to understand the climate information service that we are disseminating. So I can say capacity building is a key here, and also integration of indigenous knowledge to understand how farmers understand their farming system is also very important to make that to make sure that the farmer knows what you are trying to communicate to them. Again, talking about where we can find the data, in my experience, there will be data somewhere. So you need to strive to get the data. I'm not talking about the quality, but there will be data somewhere. We have one of our colleagues in Erie, his name is Ram, has shown this is possible. He has aggregated a lot of data. He has collected data from different sources and aggregate those data in what we call Ag Data Hub. And that Ag Data Hub is a very useful tool for decision makers, researchers to use to utilize that data. Again, talking about the percentage of adoption, we haven't done the adoption study yet because this is the 3rd year of the experiment. Maybe when we do that, we can share. Thanks.
Do you have any?
Okay, I will try to answer 3 questions. The first one is
answer just one because we have run out of time. So one question.
I will just 1 minute. I will try in 1 minute. Variety selection, usually we have a concept here in CIMMYT that we use the MIGA environment. So we have like environments that have some similarity. So we try to use similar varieties as well. So a set of varieties, but they are similar across continents and using MIGA environments. The next one is how to verify data source in large scale simulations. So one example was when I was working with Centold and with this global simulation, he was saying, you are showing very low yield for Germany. So why is that? So it's not correct, it's wrong. So I said, let's try to see what is wrong. So here's the weather, here's the sowing date that we are using for the country. Here is the nitrogen that we are using. So we were just separating all the input data, so to see what is the input data that we had wrong. So that's how we try to identify data sources if they are correct or not. And the percent adoption to gridded outputs, I would say, is mostly for policy maker decisions. So it's like large scale application. So it's if we go to downscale these responses, of course, we will need like very more finer data sources to do different applications. Thank you.
Yeah, actually, as far as that data collection from the KV case is concerned, yes, almost all the farmers in that area, that district level, they have registered with the KV case. So basically for crop modeling purpose, that much data set is not available because they have the data set of what type of varieties they are using and what type of management practices they are following. That data you will get it. But as far as crop modeling is concerned, we need to take more data set from the registered farmers. That is needed. And as far as a communication is concerned, it is a challenging job. Anyway, after results, we need to convert that into a communication strategy, that means into a information. That is also a challenging, and we tried in our AgMIP project also that how to convert that our results into information. They're challenging, and because different policymakers, they want different type of information. That's a challenging job, and it is very great. It is a great difficulty also. Thank you.
So I'd like to quickly comment on the question on variety choice. Indeed, it's easier to pick an improved variety that is well described and well known. But I think there's this knowledge among the breeders on what a land race and a local farmer variety is. I'm picking an example think of West Africa. You're using maybe an improved sorghum in your simulation and you're worried at not matching with the local context. If you want to do a local sorghum, then you go for the period sensitive sorghum with possibly a lower harvest index. And if you do that, you'll still be better than just using an improved variety. And this would work in different areas, different crops, I think. And then quickly on the comments from Vimbai, I think the CAROP data is this EIA initiative of gathering all the on-farm data that is available across all the trials that have been done by the CG centers over decades. This is very useful data for modeling, but we have to be careful on the misuse of that data. Because if you're using a model that simulates water and nitrogen stress and try to match that data at all costs, you end up reducing radiation use efficiency and you're happy. But that's not what's going on, right? I think this data should be used, making sure we get a good model with water and end stress, and then analyze the difference as an indicator of the yield gap, and it could be pest diseases and loss due to other factors.
Okay, so thank you all very much for listening to the presentation. To say a big thank you to our panelists. I think they have just too much information to share, so we did not respect the time constraints. So we would try to bring this session to an end and continue with the conversations during the coffee break. Thank you.
Yeah.
I think we broke the barrier. I think, Gatien, we, you know, from the title of your talk, I think we we broke the law of the lows, or we figured out, how, you know, how to break that law. Okay, Eric's going to lead the report backs.
Yes. So as we had said, we had to skip the report backs for the Monday sessions yesterday, so we're going to try to do that, and the working sessions from yesterday. So we're giving you maximum 2 minutes. So, and you can just do it from where you're sitting. I know some of you prepared slides, thank you, and we will have those for the report, but we won't show them because it would take too long. So, GGCMI, Jonas or Christoph, one of you want to give the very quick report back?
Yeah, cool. Hi, Jonas Jägermeier with the GGCMI and Christoph Miller. We had a marathon session on Monday, 3 hours internally and then 3 hours more of an open discussion. We had a deep dive in protocol development and how to create data sets and how to deal with fertilizer applications for crops all over the world, how to deal with planting dates in future scenarios. We had amazing discussions, and I think this is why we're here. Very engaged, great across different communities. I was very pleased with that. Just real quick, the future activities that we lined up and that we were getting ready for include a dedicated ozone comparison. So there's a collaboration between AgMIP ozone and GGCMI. So we're inviting folks to simulate ozone responses if they can. So reach out to us or Jose Gorin, who's leading that initiative. Then the big main GGCMI activity this year is a future adaptation and management scenario activity, multimodal assessment of more realistic climate change impacts. Previously, we have isolated the climate. Now we want to see what we can do on the management front. We have activities on extreme events attribution, and then down the line, we have a dedicated activity on evaluating nuclear conflict effects on global food security. And then we're getting ready for IPCC 7, CMIP 7, Q4 26 will be the fast track release of climate model simulations. So we will be ready, push the button and have a fast track assessment. We have a couple of discussion points that we may be able to cover in the panel later or during coffee break. I think I used my time.
Great, thank you. That's why I start with the Germans. So wheat, Frank or Pierre or Heidi?
Hello, so we had 27 person in the room and 29 virtual, so it was quite successful. The end of the meeting was to discuss the progress and investment in the last year of the wheat team. Actually 6 months, because we met in China in July. The objective was also to plan for future activities and workshop and develop a joint AgMIP10 application. So we reorganized 2 years ago the way we work in AgMIP10. We kind of decentralized the leadership with now kind of independent teams working on different activities around CO2 response, pest and disease, soil temperature, ET, nitrogen, and water logging. And we also interact a lot with the ozone team as they work on wheat and the calibration as well. The application we are planning is on risk assessment of nitrogen leaching and N2O emission with improved yield. It's a kind of follow of a study we published last year in Nature Plants, where we analyzed the potential of increase of yield using the latest material from CIMMYT. We showed tremendous possibility of increasing yield, but we also show that it will require a lot of nitrogen. So now we really want to see what is the risk of improving that much as required to increase the yield, the nitrogen. Thank you.
Thank you. So I'm going to ask Herman to get ready for global econ, but Jose, I think we have you online and you could give the ozone one. You can start talking now. Otherwise, I'll go to Herman.
Okay, can you all hear me?
Yes, we can hear you.
Okay, great. Good morning, everyone. Yeah, so the update for the AgMIP ozone side session was that we wanted to provide a status update on our recent activities in phase 1 and phase 2, focusing on the protocol and results. So just a brief rundown. So phase 1 is a model calibration and evaluation study that's being led by Lisa Emberson, University of York. That study is almost finished. It's wrapping up. She's in the middle of preparing the draft. And phase 2 is the global climate change assessment with ozone effects. So essentially, that's what both Jonas and Pierre were referring to. That one is open and ready to join, and we have participants from both AgMIP Wheat and AgMIP GGCMI, and so we were providing updates for that, and then we were also discussing future research plans such as incorporating satellite data into ozone climate assessments, a UNEP FAO food policy project that we are working on, and then this may be relevant to many people in the room. The IPCC AR7 author nominations are going on right now. I believe it's another week or two for the nominations, and we just wanted to make sure that we had somebody with some strong ozone representation there. And then one of the highlights of the meeting was actually that we extended the collaboration to the InfoCrop modeling team. So Dr. Subhash actually indicated the intent to participate in phase 2, which is great because that's the goal of AgMIP is for networking and collaboration. So having another modeling team participate in the activity is phenomenal. And then, yeah, so next steps are to prepare the papers. And then one highlight for a separate study is that there could be a huge potential for the development of a global database or map of different cultivar ozone sensitivities. So in other words, how we have like crop calendars, and masks for that. If we had a mask for the ozone sensitivities, that's a huge area of potential exploration, and it could be a pretty cool study. So that's a really nice area to explore. And our next meeting is scheduled for May. Thanks.
Great. Thanks, Jose. Who's doing global econ or Lancet report from? Seems like we do. Who's going to do?
Yeah, well, this is for both, actually. I'll just do a quick summary. Hi, everybody. At Springer University of Minnesota. Yeah, I wasn't at Monday's meeting, but I know the top things you all talked about were the Eat Lancet 2.0 work, as well as circularity in ag and the food loss and waste. So those were some of the big things that came out of the global econ from Monday. And then on Tuesday, we had a lot of items we discussed.
including how to link models and data across scales via improved national models in key countries, bioeconomy scenarios, connecting econ and water and land use models, properly costing no-cost solutions in non-econ models, accounting for imperfect competitiveness and information in our econ models. I'm sure I'm leaving some stuff out, but we did discuss 3 key items for moving forward on. The first one was to develop possibly a new SSP 3 or 4 plus scenario, we called it, to reflect a possible world path of higher tariffs, less spillover, less migration, less knowledge sharing. So tried to update the way we're thinking about those SSP scenarios. Also talked about biodiversity, planetary boundaries, and SSG context as a new way forward. And then finally, we also talked about distributional aspects among households and connecting local to global by assessing impacts on poverty and dietary agenda. Thank you.
Thank you. So for Monday's low input systems, Antoine, I guess.
Hi, Antoine Codel from CIRAD. So we had a productive meeting on low input systems on Monday. So first we shared results we had from phase 1 and phase 2. And one of the conclusions we had is that soil organic matter mineralization was super uncertain between different models. So then that's why we proposed a phase 3 exercise on this specific topic with plant nutrient uptake as a proxy of nitrogen mineralization. And then we also proposed to get datasets from different sites or diversity of sites. So the protocol is still ongoing. We'll hire a postdoc, so we'll circulate this offer in AgMIP. So if you know somebody that is interested to do a postdoc in France, let us know. The second part of our meeting was about the intercropping intercomparison led by Adam. He presented his conceptual intercomparison that will lead to the submission of a paper soon, I guess. And also we discussed quite a lot the data sets that will need to be collected and also evaluated for this exercise where he's comparing like 8 different models. So yeah, I think that's it. Maybe the next steps very fast. So we may consider other continents than Africa in the low input systems to look for more data sets. Still looking at tropical conditions. And then we may share clear data sets with the larger groups. We may also want to contact GGCMI models on also new conceptual models to try to check how very different models deal with soil organic matter mineralization. Thanks a lot.
Thank you. So in the last Monday session, calibration, I guess, Daniel.
Thank you. So yes, we had a calibration side session on Monday. What we did was we presented and described and explained the AgMIP calibration protocol, which we are proposing as a generic calibration method for our crop models. And we described the software that is available for doing part of the calculations that will be extended to be able to do all of the calculations fairly soon. The next steps are to test this protocol much more extensively. We've already tested it on several models and one specific data set. We really need to test it on on other crops and other data sets. If anybody's interested in working with us on doing that, we'd be very interested. After that, we had a very interesting and wide-ranging discussion, which covered things like, what are we really doing when we do calibration? Are we trying to estimate parameters that are constants of nature that we just have to estimate them once and they're known? Or are these fudge factors that are just in regression coefficients? Or is it some intermediate situation? We talked about the data available for calibration. How does the calibration depend on what the amount of data is, and what can you do if the data that you have comes from situations that aren't totally representative of the situations where you want to predict. And yeah, I think I'll stop there for the.
Thank you. And then just very quickly, the working sessions from yesterday, landscape scale modeling and crop loss, Frank?
To my knowledge, to our knowledge, that was the first time that topic was actually set up in an AgMIP context. And so the people that met for the first time. And we were quite surprised how great the attendance was. The room was full. And we also had a very intense exchange. We used the meeting in order to do kind of stock taking of what people are doing at the landscape level in terms of modeling activities. And it turned out there's a range of questions that groups addressed. That was not surprisingly, but it was good to have a kind of an overview of what's going on. And also the type of models that they're using, modeling approaches, quite diverse, depending on the questions they're addressing. And the same actually applied to the aspect of the crop losses, quite a range of topics that fall under that umbrella topic of crop losses. So we pretty much got a good overview of what's going on. Then we discussed of how we should continue with that. And there was the perception that there is a great demand for further exchange on this item. But we are far away in order to have a concise team of modeling activities. So the first thing that we would do is with a smaller group of people to sort of get an overview, conceptual overview of what is going on, the different types of approaches, and get some systematics into that, and change that with a larger group and follow up in the context of that larger group in order to then define the next steps. Thanks to everybody who contributed to that meeting. That was a great experience. Thanks very much.
Thanks, Frank. Crop model improvement, Once?
Monse Salmeron. Yesterday I was chair of the crop model improvement session. So we had great participation and discussion. First, we identify the current activities where folks can participate. So anyone interested in, there's several activities within the wheat team and also activities in the soybean team. So any modelers and experimentalists interested, I can contact the leaders of these teams. We also discussed the opportunity to restart the maize team and also exciting a new cocoa and coffee team. There's a leadership opportunity for canola and to lead new activities within barley and potatoes. So anyone interested, please step up for those. Highlight was model improvement efforts within the GGCMI focus on waterlogging and freeze damage, which takes me to a high point in the session was a lot of interest and discussion on cross teams collaborations. For example, for including improved processes across different species. So there's a lot of opportunity with current teams to collaborate. There was also interest in rotation, summarization, residue studies that can be cross-sectoral. But there's need of further discussion to define a structure for teams to collaborate effectively and share data. So I hope we can continue that discussion.
Thank you. And then machine learning and data assimilation. Johannes, I think. Yeah, we had to bring a lot of extra chairs into that room.
Okay. Yes. Okay. So we had a very nice discussion yesterday about the activities of AgML. We did a retrospective on what we achieved. We have a position paper coming up, a new benchmark data set that will be hopefully published soon. And we were looking forward for the next steps and what is coming for the next years. If you're interested, join us at agml.org. Thanks. And hybrid modeling, yeah, that will be our, we will have a webinar series for that. When we organize it, we will let you know. You wanted to say things? Yeah. Thank you.
Okay, thank you, Johannes. And I think so, we already did economics and trade, right? That was combined. So, okay, so that's it for the working sessions. So if back there, I don't know if there's anybody back there, if they could bring up the slide with the agenda, but otherwise I'll just read it off. But yeah, it's very small, but because we're not gonna come back here to plenary for a while, So first of all, it's 10:30 already. So we are gonna do our group photo. So don't start getting food right now, just walk out. There will be, people will hand you your hat and guide us to the location where we'll take the photo. After that, you can come back and have some coffee. The posters are all set up, so please go stand by your poster if you have a poster and go ask questions of the poster people. And then straight from there, so at 11:30, we'll go to presentation sessions. There's the breakouts. Then we have lunch, same location as yesterday. The theme this time will be gender. So let's try to have at least someone who identifies as a woman in the table. And there'll be questions on the table for discussion. And then right from lunch, again, straight into breakouts for the working session. So again, you can find your room, then coffee break. And then at 4:30, we'll have our closing plenary for the day. Thank you.
Start.
Okay.
Pardon?
May I have just one second to mention something?
You want to mention something?
Yeah.
Okay, before we start, we have one announcement.
Yes.
Please.
Yeah, good afternoon. We just sent an email to everyone that is participating. In case you would like to shuttle a service for your departures to the airport, we have received already 10 requests, but in case someone else would like to request that service, please don't hesitate to fill in the form so we can suggest a time for you to arrange. So thank you. That was
Is this the shuttle for Friday and also Saturday?
Yes.
Oh, okay.
Yeah.
Okay.
Okay, so
Thank you.
please fill in the form. Thank you.
Is there a deadline for when they should fill out the form? Yeah, so just to be clear, deadline today. So just if you want to shuttle to the airport tomorrow or Saturday or whenever, Friday, by tonight, you should fill out the form.
At the latest tomorrow morning. Just in case you have the whole night to decide.
Please communicate that to the others as well that are not here. So welcome back to the plenary. We're nearly at the end of the second day. For some, it's already at the end of the third day. We've heard many exciting presentations already and discussions. And you may think it cannot get better, but I think it will. Because we are now in the crop and livestock modeling session. And we have a great group of presenters and panelists. And before we go into the introduction of the colleagues, I introduce myself. My name is Frank Ewert. I'm from the Leibniz Center of Agricultural Landscape Research at the University of Bonn. And I have the great pleasure, together with Monsi, to share the session this afternoon. The topic is on crop and livestock modeling, and it is very relevant. It came up in several discussions already, and we are quite happy that we have a dedicated hour now to go a bit more into depth and also have some discussion on some of the challenges that we're facing in this regard. Before Monsi will introduce the first or the keynote speaker, perhaps a couple of comments of how we've want to organize the session. There will be the keynote. There's time for a few questions. And then we have the panelists. They have short statements of about 2, maximum 3 minutes. And we would use most of the time basically to discuss among the panelists, but also with you, with the audience, on some of the issues that come out of the presentation, but also then from the statements and the discussion. And with this, I would like to hand over to Monsi to introduce our first speaker.
Thank you, Frank. It's an honor to be here today and introduce our speakers. My name is Montse Salmerón. I'm at the University of Kentucky, and within AgMIP, I contribute to leading the soybean team. So our keynote speaker today is Heidi Weber. Dr. Heidi Weber is a system agronomist with a focus on climate risk management in the context of smallholder farming systems. Her research uses a combination of on-farm experimentation, process-based crop model improvement, and model-based climate risk and change impact assessment at field, farm, and regional scales. Her model development expertise is in the consideration of multiple abiotic stressors on crop growth, particularly the interaction of temperature, and drought stress controlling canopy temperature. Her research also explores the integration of biophysical and bioeconomic modeling approaches to assess climate risk to cropping systems. Heidi co-leads the Agricultural Landscape System Research Area at the Leibniz Center of Agricultural Landscape Research and holds the Professorship of Integrated Crop Systems Analysis and Modeling at the Vandenberg University of Technology in Germany. Welcome, Heidi.
Thank you very much, Monsi, and it's such a great honor to be here, but I am actually a little bit nervous to speak to a group of experts in crop and livestock modeling, because I'm not per se that expert, but really exciting, and let's see. What I would like to... The clicker? Okay. What I'd like to touch on today is actually maybe a little bit more superficial, and I hope I can guide us in a reflection. And I'd start that off with first thinking about what are the demands on us as crop and livestock modelers. Then I want to switch over and kind of look at what we're doing and really celebrate some of the great work that's happening in the AgMIP crop and livestock teams. And then finally come back and see how these two elements mix or match, what the demand is, what we're doing, and open up a discussion on how to go forward. Click. But I have to start with this because we are not just crop models or livestock models, we are modelers. And I thought it was interesting to take a reflection on who we are as a community. So when we're here in this room, we're people and friends at this point coming together from all over the world. And I think AgMIP needs to really be commended for the efforts it also makes to bring together some of our key team members that maybe don't have funds from their home institution. But when we look at the top publishers, and this is from Web of Science, and it's certainly not scientific, but I took out the top 100 publishing people in crop modeling. This is not livestock. And you see the first panel shows that over 50% of these top 100 publishers are from Europe, another approximately 25% North America. And there were no Mexicans in this North American list. And then another 10, 12% from China. And the other is Brazil, with 2 and 1 from Korea. So I think we missed some important voices, and especially since when you look and see where crop models, which regions we're publishing on, it's often in parts of sub-Saharan Africa, South in India, South Asia. So I think we can do better in our own institutions about thinking about collaboration. And then the gender one of these top 100 publishers, 87 were men. And yeah, I just think it's worth putting that out there when we want to think about how we improve. It's not only our models, but it's also how we are and how we work. And that's okay, so I'm about to present something even less scientific and systematic. And this is essentially, I reached out to some experts in the larger agricultural and food systems sectors. And I asked them, hey, what would be your wish for crop modeling? And we'll start with some colleagues here from CIMMYT who provided some insights. And they said, hey, we'd really like your models to be able to support us better in genomic selection. And they said, there's some interesting things going on, but your models can classify our environments, but we still have a way to go. And you'd better consider extremes, and we would like probabilistic targets. Then we asked our favorite Alex from, in his perspective from the IPCC, what do we need to deliver? And this is a big list. I won't go through it all, but maybe highlight 1 or 2. Obviously, we need novelty, new research advances. And interestingly, his second point was we need to also focus on minor crops. And I was just in the session with Mark and Dillis and Hatien on opportunity crops. So I think that's something maybe AgMIP can respond to. They also ask for a broader food systems look, so impacts on land, water, energy. They want options, they want us to identify opportunities, risks, and put it essentially together, linked to economic analysis, and bring that into policy relevant figures. Then we talked to a group of farmers from Brandenburg. These guys have farms of 2,000, 3,000 hectares, and they were not so interested in talking to us about climate change, but they were quite interested in my colleague Janu Kim leads this work, what we can help them with nitrogen, that last split of nitrogen. Can we do forecasting for them? And they were also very interested in the extremes, hail, frost, flooding, drought. And they really wanted us to translate it all to economic terms and the flexibility to explore options. Next, talk to some specialists from, and I have to qualify this again, it's from Germany and Switzerland, from the insurance industry and reinsurance. And they are actually quite interested that we put together centralized repositories of our models, open source code. They want them so that they can commercially use them and modify them. And they want excellent documentation. And they want us to document our calibration data sets and ideally with modern varieties and management. But I mean, they were not asking us per se to do that outreach, but they want to use, they leave the science to us, but please make sure that's transparent and clear. So that was another interesting voice. Then reached out to some German policymakers from Ministry of primarily, I guess, agriculture. And they again stressed the importance of a system view and how critical that was for being able to develop policies that could be acceptable to the larger public. They were interested in scenario analysis. And interestingly, they highlighted their interest in livestock models that also took a system view with environmental impacts. And lastly, no surprise, we all are part of, or most of us are probably part of the scientific system. And we know the expectation there is to publish, bring in money, supervise, and do service. And sometimes that burden can pull us quite far away from delivering these impacts. And I think this is especially critical probably for the younger or early career researchers among us. So in this complex ecosystem of demands, and I say, what is our offer? Thinking to the discussion on the science policy linkage, and they said, often you guys are just pushing your science. So I take the view here of what is our push? And to do this, Eric and Alex very kindly kind of provided me with an updated list of AgMIP teams, organized here by, I'll start with geographies, and then these are developing initiatives. They're not yet teams, but maybe they turn into them. And then the first column is where I will focus. And this is essentially on the crop and livestock teams, and then some themes and methods. And one, I reached out to various team leaders and said, hey, what's the most exciting things that you've done in your teams in the last 2 or 3 years? What are the current developments and your big challenges? And I'll just give kind of 5 exemplary examples. I will not pick out low input farming systems initially, but I want you to remember to Hatian's talk this morning because he's already given this a nice talk, but we'll certainly come back to it on our last reflections. So I start with the wheat team because it's the one I know best. And without a doubt, I think all of the leaders, we agreed that the work we've done in the last few years, also with CIMMYT colleagues on improving our models to capture yield response to traits associated from genetic variability, that current genetic variability associated with high yields. And we published model improvements in a number of papers and also demonstrating this potential to increase yields. And Pierre brought it all together in a really nice Nature Plant paper for us to really talk about the costs in terms of nitrogen fertilizer and the implications. And we continue this study now, but with a real focus looking at the riskiness of this fertilization. And as for how AgMIP wheat is developing, we're organized in a very decentral way into these 8 sub-teams. Some are very active, the calibration and ozone. I think waterlogging and ET now have papers in review process, and others are more at the level of developing protocols. And our biggest challenge is how to bring these parts back together. And So then I would flip to another crop team, and this is the soy team. And I'd say these are definitely the champions of understanding what's going on and really knowing how their models are working. I don't go through the list of this, but they are really testing the response of their models across temperature, CO2, water use, nitrogen dynamics. And the thing I would really emphasize here is they put a lot of emphasis on this in-season growth dynamics. So the kind of processes that eventually lead to both resource use or yield and biomass at the end. So I think they're a team that's very inspiring with their efforts on model improvement. So Mansi, to point you out. And I would just contrast the difference in their approach with AgMIP wheat. They're quite centralized, they're doing this together. And I think these two teams should compare notes and experiences. I take a bit of a jump, and I hope Randall is online to back me up with the livestock, because I just know I like cows, I guess. But one, Randall Boone, who is on our panel, pointed out a development he thought was quite exciting. And that was, on the one hand, model improvement to better capture animal weight gain in grazing systems, and then using this improved model in a real transdisciplinary research setting. So together with farmers and other practitioners to evaluate different collaborative grazing management. Some developments they think are really interesting to address going forward is really how AI is going to change livestock farming, and then how they will deal with that in the modeling. I also reached out to some colleagues at Wageningen, and they said an interesting aspect for them was essentially the composition of grasslands and more diversity in grasslands and effects on kind of animal farm and higher system levels. Challenge they identified was how they currently deal with herd dynamics, and that's computationally expensive, and there best be alternatives. And I think what strikes me here is very different from those first two crop teams. They're taking a very broad system view and already using their models with practitioner for impact. Now I take a switch. It's maybe a methodological team in crop modeling, and this is the AgML, the machine learning AgMIP team. It's a relatively new team, and the work that Jonas mentioned that I could highlight here was a conceptual framework they've developed essentially on how machine learning can be combined with process-based modeling to really support in the end more impactful research. And there's some examples here. I don't go through them, but I think you can read them. And this is a paper, I guess, by Lilybell Sweet, who is not here, I don't think yet. Some other exciting developments that they are both working on or see its potential. The first is maybe more developed already, and this is the integration of machine learning with phenotyping for trait identification. And another is the use of AI in agricultural extension. And the paper they pointed out outlines many challenges, but also it's an area of really great potential. And I think also this, although it's a very technical team, they seem quite focused on problem solving. And then they find the methods and model they need to solve that problem. And the last team I will highlight, and again, I miss a lot of teams, but I had to pull out this one for many reasons, but especially because Daniel and Taru, when I asked them, basically said they were probably the greatest team. They've met 100 times already, and it's very exciting. And I mean, yeah, so that was also exciting to hear how much they love their team. And they have developed, but I think, Daniel, your team is part of AgMIP wheat, so we will take that, yeah. They have developed their highlight that they wanted to spotlight was the development of a systematic calibration protocol. And I don't list all the attributes, but it's detailed, it's comprehensive, it ensures bug testing, avoids over-parameterization, and that really promotes or enables a reflective approach to all of these decisions we make during calibration. What they're working on now is testing their multiple data sets and trying to testing the protocol with different data sets and automating the process. And a big challenge for them is finding data on these intermediate processes. And I thought maybe this linking up with the soy team is maybe a nice opportunity. And their hope is that this will become standard in crop modeling exercises, and that will lead us to better quality projections, but also we can focus better on model improvement because we've removed the uncertainty of the calibration. So in this, again, complex space of demands, that was a little bit the what we can offer. And now for the reflection on how did we do? How do our demands match with what we have done? So I started off by trying to synthesize and capturing extremes showed up a couple of times. So I put that on the top. And here I think we're making a lot of progress in a lot of the teams, Gigi Semi, wheat, soy, the maize team just did a nice ET study. So we're really progressing, but there seems to be at this point limited learning between the teams. And I think that's been highlighted in various discussions at this meeting, and maybe an opportunity. Then another thing that was coming up a lot was people want a systems perspective. And again, most of the crop model teams are not doing that now. We're really focusing on model improvement. And the exception is, of course, the low input systems. They look at this whole, I mean, at this point, I guess it's with one crop, but with the ambition to add probably others, and they look at the soil system. So this is an area we should probably think to learn from that team. And the livestock team is clearly doing a systems approach. Repositories for our models and data sets, no. Integration with genetic and sensing data, I think the machine learning team steps up there, minor crops. And then at one point, I just said, wait, the point is not to list every demand, but it's maybe that we stop and take a step back in each of the teams and really say, hey, what do we want to accomplish in this team? Do we have an idea of who our demand partner is that we're working towards? What are we trying to deliver? And what are these model improvements for? And that may help us on prioritizing where to focus. So to turn that around, maybe we should, from again, the science policy linkage talks, really nice talks we heard, they said maybe you should wait for that pull. What do people want? And so maybe we could rather try to frame this as what are we, spelling error, what are we working towards rather than just putting out a buffet of what we offer. And so last slide, and maybe the panel can take up some of these points. And this would be on a high level. Maybe it's a good time to really reflect on what we want to have achieved in 5 years' time in our teams. We're very good at making plans for the next phase and the next year, but where are we working towards? And some ideas for possible developments, and I don't think it's an either or, and maybe they're contentious, but maybe we could reflect on them. So one option is maybe just maintain our current teams, but somehow promote learning and collaboration. And I think, Mansi, your session yesterday was an excellent step in that direction. A next idea that really came from Christoph and Jonas is, hey, is there a need for, and the GGSMI team, is there a need for maybe an AgMIP level orchestration of how to bring these kind of improvements, especially around extremes, waterlogging, ET, nitrogen response. Some elements are crop specific, but the soil elements, atmospheric, maybe there's an opportunity to move these out of the crop teams. We could also go a step further and look to the low input farming systems team and think, do we need cropping system teams for other regions? And maybe the biggest step at first I thought was to create interdisciplinary teams and just really focus on a demand partner. Somebody working with breeding, somebody working with these insurance people who just want our model. But and then it made me reflect on the great work AgMIP's already done in the regional integrated assessment teams. And I think you've already been to that point. So maybe there's some learning through all of these options. And the last point is also, it's not just our models we want to improve, but also our way of working. And maybe just to reflect on that, who we want to be as a community and how can we be more equitable. And I don't mean that for AgMIP, but maybe for all of us when we go back to our own institutions. And with that, I stop.
Thank you very much, Heidi. Maybe Heidi, I can, and Monsi as well. Thanks very much, Heidi, for asking these fundamental questions of where we are with AgMIP and where we want to go. Maybe you can take that seat because I have a mic already. We take first, give first colleagues a chance to ask questions about the presentation, and then we invite the other panelists and continue with the discussion. Are there any questions about the presentation? Any comments you want to make? Yeah, the very end. And maybe others can also signal, then we can allocate mics already.
Hi, Lennart Jansen from the Potsdam Institute again. Really insightful presentation. I really like the broad view of where we want to be and what we need to deliver and who we are. A question to Heidi. You are in charge of AgMIP wheat, is that correct?
I'm one of 4 people and I lead their energy balance stuff.
Then I will just ask your opinion as one of 4 people. Where do you see AgMIP wheat in 5 years? What would your goals be?
Well,
unless you can be short, Heidi.
No, but I mean, it's something we've discussed in the team, and I think there's our real leaders really unfortunately not able to be with us, but we've discussed that. And I think one direction we definitely want to take we want to start to see how we can consider biodiversity. And we definitely want to take this step to a cropping system approach, but we need partners for that.
There was another question.
Actually, maybe just more of a comment. I really appreciated the presentation. It was really nice to visualize all those aspects that were shared, and the value of that for moving the agenda forward is very, very evident. And I guess I hope that all of the groups here recognize that something like this can keep in motion. So it's not just individual personalities, but it's actually the cohesion that comes from seeing it from both perspectives, the science towards the goal and the goal back to the science. So thank you. It was really, really nice.
Thanks for this feedback. Are there any more questions? Yeah, there's a hand up there.
Yeah, I think I echo the same sentiments as the previous commenter. But my question is now related to probably AgMIP is going through a phase where we have well-established models and also outputs and outcomes around those models. And we are entering into a phase where we're looking for the next big innovation, opportunity crops, mixed systems, integrated systems. My question now is, when is enough enough? When do we let go and pass on the baton to the next, probably team? When do we learn from our past experiences and move them forward? Because sometimes I feel as if as modelers, we always want to go down this rabbit hole and we dig and dig and dig and open up new tunnels.
Yes.
Yeah, I think from my view, that is the question. And I certainly don't have the answer, but I understand that we need all types of people. We need the people that go deep and really understand the processes and make sure we have good models. And then we need the people that are also making that outreach. But I'm not the person to answer, but I think it's a great reflection.
Perhaps we can reflect on this question again in the panel discussion when we have also the other colleagues here on the panel. I'm checking again, are there more questions? Then I would like to invite our panelists, Jonas and Santiago. Please come and join us. And we have one colleague, Randall, remotely. And Monsi will sort of introduce our colleagues.
Our next panelist is Santiago Cuadra. Santiago Cuadra is a researcher at Embrapa Digital Agriculture. He holds a degree in meteorology from the Federal University of Rio de Janeiro, a master's degree in meteorology from the University of Sao Paulo, and a PhD from Federal University of Viçosa. He worked as a professor at Cefet RG between 2010 and 2012. He has experience in the area of geosciences with emphasis on climatology and climate change in South America, regional climate modeling, modeling of the biosphere, atmosphere, hydrosphere interaction, and biophysical models of agricultural productivity. He's currently working on the development of biophysical models to assess the impacts of climate on the development and yield of agricultural crops, measures to mitigate greenhouse gas emissions, and the impacts of climate change on Brazilian agriculture. Welcome, Santiago.
So I put some slides, okay, you can see, not in the TV, but can I stand up? Okay, okay, thank you. So the idea is to bring some challenges in Brazil about the modeling. So next, please. So this is the years 2014 until 2 years ago, and this is the private sector numbers, and this is the insurance that's paid directly for the government to the small farmers. And we can see here clear that something is not going well, right? The numbers of the insurance are just not, if it was not the reinsurance companies, most of the companies probably is going to break. Next, please. And one of the reasons, not only climate change, but one of the major reasons is the adverse selections. The problem that most of the farmers that contracted the insurance are dead guys over there. So we have a very challenging, not only to try to evaluate the risk of different farmers, different levels of technologies. We have to simulate that, and these make a lot of difference. This we have done this already for soybean, and probably this year is going to take place. And but to have to do that for many other crops. So this it's a very good and very difficult challenge for modeling. How we really simulated the different measurements and the effects of that in the resilience of the crop systems. Next, please. And one of the problems is that that slide shows many processes that has happened. And we can see here that we are very good in simulate some of them in the last decades, but some of them we are not as good as simulating. And some of them that we already think that we are very good. For instance, this is the paper of that Monsi is leading, is not published yet. And this is the sentence of the paper. There is a need for models to better account for crop surface residue decomposition, the effects on evaporation. So we expected that we are doing well in the last decades about that. And we can see here that there are many processes. The biological process, the soil health, it's a new universe. And we have, you have to, it will be a new challenge to make part of them, and then how you modeling the effect of that in the crop resilience. Next, please. Another challenge also about the grazing, and we are seeing that we are very good in simulate the rotational stock systems because that comportment is similar as crops. So we are pretty good on that. But this is the major reality, at least in Brazil, I guess, for most of the countries also. And we can see here, this is simulated and observed. This is a very, very difficult challenge because they would have the interaction of the animals. The farmers has very different measurements. So it's, I think for us, the major challenge is for simulating the grazing, it's how to simulate the interaction with the animals. And the last slide. Oh no, sorry, not the last. The other thing that we need, it's different crops. We in Brazil have the insurance for 45 crops so far. And you can see here the diversity of the risk assessment for different crops. So we can see here by the list for the AgMIP that we have a lot, I don't know, 5 crops, the groups. So, and we have very different, I guess, in Africa, in Brazil too, especially in the tropics. And this is a very difficult challenge for us. And the next one, the last. And in terms of landscape simulations, I think we are pretty not good, but we know we have been successful to scaling up models to go, for instance, in the culture evaluations, but we are not so successful to do simulation at the landscape of the farm level. I don't see many farmers using models actually in the reality. Otherwise, in the scale of landscape at a state or other scales, we have been successful. So I think this is a very important challenge.
Thank you, Santiago. You brought really interesting points and challenges in modeling. We'll hold our questions till the end of the panelists. Our next panelist is Jonas Jagermeyer. He's a climate change scientist and crop modeler. He studies food systems and global food security at the NASA Goddard Institute for Space Studies, the Climate School at Columbia University, and the Potsdam Institute for Climate Impact Research. As a central initiative within AgMIP, he co-leads AgRIC and the Global Gridded Crop Model Intercomparison, and is the coordinator of the agricultural sector in ICIMIC, a cross-sectoral model intercomparison project. Using global mechanistic crop modeling, he addresses questions related to climate change impacts on agricultural systems, the role of extreme weather events, end-of-season yield forecasting system, developing pathways for attaining the SDGs, and how to feed 10 billion people with environmental limits.
Okay, thank you for the kind introduction and having me on the panel and letting me share a couple of reflections. What I thought to do is tie together a couple of observations I had throughout the conference. And as Heidi mentioned, there's discussion points that keep coming up. And they kind of, I have a little bit of a list to get lost, but they kind of come back to that theme of limited integration across teams. And I think there's a lot of room for better collaborating and synthesizing efforts and findings. And in my eyes, they break down in 3 categories. Okay, so, or to start with an example, I'm with the global crop modeling team. There's a lot of effort in AgMIP wheat. There's a low input systems. There's a calibration system, calibration group. But we hardly know what's going on in these different groups. And there's a lot of lost co-benefits that we can use more efficiently, I think. And my 3 themes here are, there's the science basis. And I would love to see more of an orchestrated synthesis of science. And that's the biophysical understanding, that's the code implementation, and to share findings hierarchically in a vertical way, but also in a horizontal way. And I think that would benefit everybody. And then there's the question of data repositories. And that also came up in your presentation, and a little bit ashamed to just echo your talking points. But I think that really stood out and was brought up by a couple of folks. And if we want to calibrate an ozone model and have to do the legwork again and reach out to the community worldwide and try to find experimental data, that's an inefficiency. And we have the data in AgMIP, and it's a low-hanging fruit to create a data repository, a dashboard, a platform where each of us can go and just look up what kind of data do we have, what models do we have, and make it easily accessible and transparent. I think that is a great lever for increasing efficiency. And then reflecting a point that Christoph made too, and a couple of other folks, is again, horizontal and vertical integration of findings and policy advice. So have talking points ready, have insights, conclusions ready across teams and not in isolation. Why is the soybean team their own talking points and the AgMIP team, and then we in GGCMI find something out and find ourselves in a similar boat. I think there's a lot of room for synthesizing findings. Now, of course, this is easier said than done. I think there's something like that needs a little bit more of an organizational body. So it's effort. And again, funding would help, but I think there's also lots of things we can do just by increasing efficiencies and cross collaborations. And maybe we can look a little bit to industry and to the private sector, the term ROI, return on investment. In a company, you wouldn't see that. You would really make sure that whatever's found out in one team makes its way up and across teams to be useful for everybody else. So again, efficiency. Yeah, maybe as an example, we're working on water logging. That's a prime example that we have different initiatives going on right now. And we don't want to redo the work. So I think that's what I said before. Extremes is a big thing. So we certainly want to coordinate in that. And then maybe that was a discussion point we had in one of the side events. There's a pro and a con to harmonizing too much. Of course, you can say, yeah, we develop a module for water logging and then put it into a repository and everybody can plug and play that into their model. It's not that easy because that module may not work in your model because it's calibrated, parameterized in the wrong way. And there's also a point to be made about over-harmonizing a model. There's merit in having different models, having a diversity. So I would love to see more of a discussion around where is it useful to harmonize the community, to structure the community a little bit, the science implementation a little bit, and where do we want to stop or simply can't. I'll stop here and look forward to questions and we take it from there.
Thank you, Jonas. We have the questions at the end. It's great to see all this interest from everyone in integration and collaboration, and we'll be excited to discuss how we make that happen. Our last panelist is Randall Boone. He's joining remotely. Can you hear us?
I can. That is a very big face behind you. I apologize for that.
Well, thank you for joining us. Randall Boone is a professor in the Department of Ecosystem Science and Sustainability, senior research scientist within the Natural Resource Ecology Laboratory, an affiliate faculty member of the Department of Anthropology at Colorado State University. Randall is a wildlife ecologist, but his expertise is diverse, including research in ecological modeling, spatial analysis, landscape ecology, geographical relationships, species habitat relationships, couple system modeling, and wildlife and livestock mobility. Reported in more than 90 publications and 20 book chapters, Randall's current research analyzes how landscape fragmentation can alter the number of livestock and wildlife that can be supported on an area, continental scale ecosystems modeling, agent-based approaches to human food systems, and optimizing herbivore access to forage using evolutionary computation. He teaches courses in ecosystem science and agent-based modeling of ecological and social systems. Welcome, Randall. We look forward.
Well, thank you. I do appreciate it. And my apologies for not being there. I would rather be with you. And I do appreciate the invitation and keynote and such. As you mentioned, I do a lot of agent-based modeling. That's my primary touch point in livestock modeling. And we were asked to consider a couple of points just to touch upon, perhaps a challenge or two. And in the context of agent-based modeling of livestock and their movements, one pathway we're pursuing now and have been for a little while is so agent-based modeling representing individuals, their interactions with each other and the environment. That's kind of definitional. And then we have worked to bring in a pathway that represents the personalities of the livestock. It's a strange way to phrase it, but Bailey and others early on identified that there are personalities associated with these livestock. And we can represent that in a modeling context. And so we do. We have a small portion of the individuals that are leaders. The bulk of the individuals are followers. There are independents as well that seem to be on their own, doing their own thing. And we can represent that in an agent-based setting. It does speed model computation to a degree in that the leaders are the ones that are assessing the quality of the photo landscape, for example, and making decisions based on the forage available to them and such, whereas followers are constrained in their distribution to be near leaders. And we can do things like change and alter the herding tendencies of animals. We've looked at things like the utility of using animals to graze heavily areas that might have poisonous plants, for example, to reduce animal losses. One of the issues is that it's computationally expensive to do, and we haven't really quantified to a great degree the utility of representing those kinds of details. We always want, of course, the modeling that we do to relate back to the scenarios to be addressed, to relate back to the questions of interest. But here it does seem to give a more realistic representation of animal movement and such. Another pathway that we followed that has been around a long time, of course, is through linking forage acquisition and from that energy acquisition to the energy use of animals. And that allows us to incorporate a whole suite of attributes, including things that relate to climate change, like thermal tolerance and such, and difficulty in moving through snow and what have you. And so we can incorporate those into a model. The real beauty of it, though, is that we can then compare. So that's used to calculate weight change through time in our discrete time models. Then we can compare that to an expected body mass. And that's really where, that's what allows for the coupled systems modeling that we do in East Africa and elsewhere, because we can say, well, the animal should be at this weight, but it's at this weight, convert that to a condition index. And then that condition index can then relate to things like death rates. And that's what kind of connects the ecosystem services that are provided to families and the performance of their herds. And so it's an intriguing thing. Again, questions and challenges over how much detail we need. I'm working at a continental scale right now and wondering, I don't believe I will, but wondering if I'll need individual landscape parameters to control livestock dynamics, or can have one single value for a given query applied to the whole continent. But interesting questions. And again, appreciate the invitation and looking forward to our discussion.
Thanks very much to all of you. And perhaps we start the discussion coming back to the core aspect of Heidi's presentation, where she sort of put up all the demands from the different stakeholder groups, quite an array of demands, and contrasted that with our capabilities in AgMIP wheat. And I sense already from the feedback that there is a challenge in order to match demand and supply of what we can offer and what is needed. There was one comment asking, do we want to perhaps too much in order to perhaps satisfy all the demands that are being put up? And perhaps that is the first question to you. Is that all possible in general? Is that something that may overload us? Or is there still an aspect that we can perhaps through reorganization, better organization, achieve many of those demands that you have shown, Heidi? Who wants to make a start? Yeah, please.
I think it's hard to just, I mean, and we heard the science policy experts yesterday say, you push, I mean, this push-pull model, and we can put out all we want, but in the end, they want specific things. So maybe it's good to think of some people really just working on the core model improvements, the uncertainties, making sure we have good tools, and others just really doing that engagement already with people who want to work with us and like listening what they want. And yeah,
So
not
that-
waiting for the perfect model because we'll never have them.
So that would mean different groups of people linking up with different stakeholder demands, different stakeholders. Okay, what do the others think?
Well, I saw a call for uncertainty disclosure, which was very surprising out of the policy feedback, and we can certainly deliver on that. So that's not a big ask. Usually it's the other way around, that journalists and policy wants one number and we give them a whole error bar. So that's good to see. In general, I think there's a lot of capacity, experience, expertise all across the field. There's certainly something we can do streamlining that better and have the model that know the strengths and weaknesses of each approach and model and apply them in a specific way. But also one thing about our, we're often a little bit too careful about, at least in my group, to expand, for example, the additional crops. We say, well, we don't want to go past the 4 big commodity crops because we don't really have the expertise. And maybe it's time to rethink that a little bit and say, well, if we provide it with enough context and disclosures, I think it's okay to put out a result for an additional crop where we only have 1 or 2 models and not 15. So using the capacity we have in slightly more efficient ways, I think can go a long way.
Would it also have an implication on the structure, the way we are presently structured in the different teams, along crops, perhaps across scales? Would it have an implication what we're discussing now, or can we still, with that present structure, accommodate many of the demands that are being out there, and which we would like to satisfy? Anybody who wants to make a start? You tell me if we can also open that up at some stage. How do you feel about that?
I mean, I think it's something that needs a bigger discussion because these teams have formed and they've been so successful because the people love working together, and if they're motivated to also do good science. So, but maybe it is a bigger discussion, I think. Yeah.
So if anybody wants to join or has an opinion on that, please feel free to raise your hand. I see Mario up there. I see Baron up there. Mario has already a mic, so you are the first.
Hello? Yeah.
Hello.
Thanks, Heidi. Well, what I'd like to say is that the teams have been successful because there is a policy demand for what they...
Your mic is...
Push it up. Hello? Okay. Yeah. So the teams that have been successful because there is a huge demand for what they're doing. So they might have started as a model intercomparison, but very quickly things changed to respond to user needs. And I think that you mentioned it rightly so in your presentation that it's the critical thing. Where is the demand? And at least the experience of the global integrated assessment models is really, trying to satisfy the demand of different communities. The IPCC community working on climate change, definitely, but also people interested on the future of food and the likes. And this creates a completely different ballpark because it's a lot easier then to raise money for conducting those studies. And so in this day and age, the time where we can just work together just because, we're doing really, really cool things it's more difficult to achieve that unless there is that demand element that really pulls us to have to work together.
But just to quick follow up on this, Mario, the demand, I mean, do you question the demands that have been put up by Heidi as something we should look at?
Oh, absolutely. Yeah.
Absolutely.
I think that it is AgMIP's responsibility to work on demand-led problems. And that's how we create, well, you know, we get the credentials, we get the honest broker, the key partner kind of moniker that we all need then to find the funds and find the way of doing modeling that helps humanity.
Aaron.
So if I kind of pick up on that, it's working? Okay. So if I pick up on that, the success of the example just given initially was tied to an obvious demand. And so it was relatively straightforward to coordinate, I'm guessing, I wasn't there, but to coordinate towards that demand. But my guess is that Heidi and maybe everybody in the room probably is not aware of many of the demands that ended up on that map that was shared. Quite powerful to look at. But as we become much more mature on the scientific side, then the unknown of what the demands are becomes more obvious because we've already ticked off some of the big ones, right, that we were addressing. So to map that in each group and then potentially across groups is powerful. It doesn't require that the work, the push, fills those demands. It becomes an awareness and a decision that's made in the group. And also it creates an opportunity for this group to grow, right? Because there could be a demand that is very serious, but the right types of modelers are not here or what have you. They might join because the other types of modelers are here and they can come into play. So I think that having a systematic way of trying to keep up with these different constituencies and their demands, and then going back to what you've got or you want to go forward. And my last comment, one of you mentioned do we refine the models or do we change, right? And I think that's something that is important to consider, right? It was talked about in the group I was in just a little while ago that the relative impact of that fine tuning may be important scientifically, but have no impact on the end use, right? And are we checking that? We could potentially put in a mechanism to check.
Yes, these are the
right.
different types of demands that we are then confronted with that require different responses. Jonas, a quick response to that while Herman gets the mic. He had a hand up.
We also have a comment online maybe after Herman.
Yeah,
what was that? No.
Let me
We'll
just
do that
respond
after-
real quick.
after Herman.
It's short. Demand is obviously, important. We want to cater to the demand, but it's also funding driven. And sometimes you simply can't choose. And the funder approaches us with a specific scope, and then we try to deliver. Fair enough. But model development is very, very rarely in the focus of a funder. So there's, I think, something that we have to, a momentum that we have to generate intrinsically and responding to a specific demand. And I think we need to take care that we make sure that we also do the stuff that's happening behind the scenes
But that can be quite fragmented. Huh? There may be some money coming for certain topics here and there. If you try for an overall picture of mapping demand and supply and see what you can build up, it's a more systematic, structured approach to that. I guess somewhere we have to find our way around that, I would think, and maybe not something that we can answer in this round today, but maybe something that can be answered in the leadership round of AgMIP. But I would like to then give the word to Herman, and then there was someone online.
Yeah, thanks. I have a specific question to the crop modelers because it's the largest group in AgMIP. And I mean, Heidi, I like very much your map, and this refers to breeding and the breeding sector. I mean, obviously breeding, I mean, here we are at CIMMYT, right? Breeding is incredibly important. It has been in the past, it will be in the future. And from the very beginning in AgMIP, we have always talked about this. Isn't this interesting what comes out of the crop models for the breeding sector? And then there's huge research programs on whatever, new biotechnologies and so on. Can this be created? You know, what's the status there? Is it working? Why is it not working? This seems obvious. And yeah, what's the state there?
I would say you're sitting, I mean, there is some excellent work going on there by some teams in Australia, the teams of Pierre Marc, you're very well connected to that, Fred and Wageningen. So I don't think that's a core activity in AgMIP, but Pierre, do you have a comment or answer to that?
No, just a comment to say that the only funded project we had in AgMIP10 was on breeding. It was funded by the wheat yield partnership with Cement. So it was on breeding.
We have an online comment.
Yes, so from Alex. So Alex, can you, yeah, there we go.
Yeah, hi everybody. Great to hear this panel. I just wanted to address the questions about how we can better integrate across teams. And I'll just remind of a couple of things. We have a quite powerful AgMIP listserv that I hope everybody who is here is subscribed to. I think it's underutilized. I think teams should better announce and more frequently send emails to that broader listserv. We don't want to get 1,000 emails, but when you have a new initiative, when there's an exciting paper coming out of the group, these types of things should be shared and we'll get the news out. We also have a newsletter that Natalie helps to run, and we have website locations for almost all the teams. These are how we can get more word out to collaborate on the various initiatives. I'll also note that the global workshop really is the best chance for this. So I'm preaching to the choir here because you're all there doing just this, but it's another reason that it's important for us to have regular workshops. And even the team workshops almost always have open doors. So leaders from other teams, if you're interested, almost certainly can show up and participate in those workshops to increase cross collaboration. Finally, I'll just note that on social media, AgMIP is now on Blue Sky. We have an AgMIP starter pack. So if you want to do the social media stuff, you can follow us there. And that would be another place to learn about new papers and initiatives. Thank you.
Thanks, Alex. Perhaps we can take a couple of more minutes. We started a little later. Perhaps on a short reflection, whether there are any immediate ideas on structures, on support that we would need in order to advance along the lines that we are discussing right now. Anybody who wants to make a start here from the group, and then we open up again?
Yeah,
Fiona?
okay.
Yeah.
I will do a reflection about Brazil. We live under the pressure of the private and the government sector because we work directly with them. And one of for our experience, I would say that we have a lot of things here going on, but one thing it's publish a paper or have some advantage in the model, and another totally different thing it's make this become a product to be used at by the government or by the private sector. And one reflection may be how you for instance, speaking about Brazil, probably that number that you show for North America and Europe, there is a lot of Brazilians over there. For instance, this side, there is a lot of group of Brazilians. So, and but not so much working in Brazil. And I guess maybe I'm not so experienced with Africa, but we can see here that one challenge could be how we do the formation for people that live in the culture and that live the problems that in your lives and work with the government directly. Because otherwise it's difficult, even though you do a nice thing, if you do not translate it to the reality and to people that could do the understanding of the other point, it will be very difficult. So I think it's maybe one good thing to do.
We touched on that point also in the session on technology innovation, that it's a little déjà vu that I have regarding your comment right now. Jonas?
Yeah, really quick final note, responding to Alex a little bit. I appreciate pushing for existing structures that we can leverage a little bit better. But I think to really unlock synergies and co-benefits, we need to go a little bit beyond that. And that requires effort from the individual teams, but also from us in the coordinating unit. And that's hard. But in order to have a data repository, it doesn't establish it itself. So without having an AgMIP10 a full-time staff member who maintains and controls and quality controls data, this is not happening. And without the effort of each team to see benefit in such a collaboration, pushing things up, but also receiving things across the teams. One example is a crop calendar in turn for an ozone calibration data set. Without that being seen and without us being willing to put in the work, I don't think we can unlock that efficiency.
Pierre and Mila? Do you have a mic? No. Who has? We do Pierre and then.
Yeah, but not just about the data and the need for IT team. I think we should analyze why the tool that have been developed at the beginning of AgMIP haven't been used. They have done very nice thing. I mean, when we say there's no data repository, it's not really true. There's a database actually, but I think nobody is really using it. But the data translator and using the ICASA format, that's really great. It's a tool I personally use a lot. But when I ask in the AgMIP team who is using it and how useful it will be to distribute the file, the JSON file from AgMIP format, nobody said no, even people from DSAT. So we should analyze why. I mean, we can do a data repository and all, but why it's not adopted? It's a problem of training, information, or it's not mature enough. People try once and wow, it doesn't work. I don't know, but
I think
we should
good
say
comment.
why the tool that have been developed at the beginning, and I see there's no IT team anymore. I think kind of, but if they were great, but not adopted.
Yeah, I think we note that whole point of the data that comes up all the time. But I would like to give others a chance. There was a hand here first, and then Christoph.
I don't know, Christoph, if you had a related.
You have the mic now. It takes too long.
It takes
to
too
move
long
the
to do
mic.
that. Okay.
Yeah.
So I have a very different, more philosophical question. So one of the things that, so I guess I'm curious what the panel thinks about levels of coordination such that you've got teams that are all working towards a shared goal versus things that are a bit more independent and exploratory, particularly coming from early career folks. I'm thinking about this in relation a little bit to the funding because, I mean, Cynthia, the MAC-B funding didn't come right away. We sort of generated those ideas and then alignment happened later, but I wouldn't say that the demand was there initially years before when we were conceptualizing some of that. And so with the climate community, sometimes we struggle because this is my opinion, but sometimes I feel like the IPCC process the CMIP process forces climate models to be doing these experiments. There's so much effort and so much coordination that's put behind that. It doesn't leave as much room sometimes for exploratory one-off crazy ideas that wind up being very generative later. And so I'm wondering what the panel thinks about that balance between responding to demands, which we absolutely need to do. I agree with Mario, but the other sort of more intellectual exploratory nature of the work that can actually generate a lot of impact. And I sometimes do worry a little bit from the climate lesson that too much coordination can tamp down that exploratory nature, but maybe we're not at risk of that anytime soon.
Yes, Heidi will give a response while the mic walks over.
I mean, you make an excellent point, and I think, though, we've just experienced at this meeting, so independently in the wheat team, we discussed the need for even in our team integrating. Monse led a great session. Jonas and Christoph have been talking about this already for a year so. I think there is also a bottom up, even from the teams, like, hey, how can we learn from each other? So I totally get your point, but I wouldn't see it as I would say there could be benefit, though, of having some higher level coordination to make that happen, but I think the willingness is there.
And Christoph, yeah, no. Still to this, then Jonas, and then Christoph.
I said enough, Christoph.
A little bit referring to what Pierre just said, I think there's a lot out there that could help us, and we are not using it because we don't have to. And similar to as journalists have started requesting that model code needs to be submitted with a paper or data has to be public, AgMIP needs to request from itself that models pass specific tests. And then we will know about data that are out there that we test because we have to test against them. We will know that there are databases. We will know that there are data pipelines. We will know about tools because we have to use them if we request that these are used in order to qualify to contribute to a study. As long as we are at the, I mean, AgMIP has come a very long way. We've built a community, we've set standards, and it's time to raise ambitions to our own work to really make this advancement in individual groups visible across AgMIP. And I think that needs to come from each individual team's leadership, and it could be an AgMIP standard that increasingly models need to pass additional tests, not just that negative yields are prohibited, and as long as your model produces negative yield, you're out, but maybe another functional relationship that is obvious and your model should capture it. If you want to do a study about protein content and your nitrogen response function is really nonsense, you shouldn't participate. But there should be a test that tells you that your model doesn't do it, and then you have the chance of improving on that using the data and pipelines that exist.
Okay, with view on the time, we perhaps slowly come to an end. Of course, the question emerges, what's next? How do we go from here? I'm not sure we will have a good answer to that, but I sense from the discussion that there is the general notion, pardon? Yeah. That there is a general notion that we have reached a point in the genesis, in the evolution of AgMIP, where we should perhaps reflect on where we are, where we come from, and where we want to go. Heidi started off by looking into the demands, where the demands may have been somewhat different when AgMIP was started. And now the range of demands have increased, have changed. Are we still in the right position? Do we have the right structure? Do we have the right instruments? Do we need some reorganization perhaps, or some new structures in order to comply to that? That we don't have the answers yet. There is some notion that something needs to be thought through. There's bottom-up initiative. There may be top-down support in that for that process, but I guess that's where we are. That's as far as we can go with that. Come with that session, and I don't know whether you want to close the session, but
no, let's close the session.
Let's close the session, and then you.
Let's clap for everyone.
With that, I would like to thank Heidi and the panelists, and also you for the discussion. Thank you. Cynthia.
Wonderful, very quick response. Thank you, Heidi, and thank you, panelists, and thank you, the participants for the great discussion. It's clear that some key future, stepping up to the challenges that we've been talking about in AgMIP is like the time really is now. So that's why we actually scheduled for tomorrow morning to continue the discussion, so it doesn't have to end here. So we're starting at 8:30 tomorrow morning. So everyone, please get up early and get here. And we'll be, I think, with the ExecCom is going to lead this session, and respond and see what directions we can't with all these ideas, but if we try to do all of them, we're not gonna. That's not a good way forward. But what are some key things, like the reconstituting the IT team, definitely, which people retire, great leaders retire, and then other folks haven't stepped up, for example. But that clearly is something I think needs to be reconstituted. But I think all other great ideas came from this discussion today and through all of this week. And let's continue the discussion tomorrow morning. Thanks very much.